Okay, so if we were to write a function that computes the a weighted mean, it would take in two inputs. So let's call this input numbers and input frequency. And then this is where like the meat of the function is going to live. So you told me that we should check whether they're the same length, right? Because it would be bad if these two integers or these two vectors were not the same length. Check if same length. What is something you can use to check whether they're the same length? Say that again. An if statement. Exactly. I gave it away by saying it for you. So you might want to put in an if statement. Does anyone remember how you can check the length of a vector? Length function. Perfect. Okay. So you will check whether the length of one function is equal to the length of the second function. Anyone know how to check if something is equal? What's the syntax for that? Yes. What if you want to check if something's not equal to each other? Exclamation equals. Perfect. So I actually wrote this out ahead of time, so I'm gonna do that. Sorry for you guys. Okay. So this is gonna check whether the length of the first vector is not equal to the length of the second vector. And if it's not equal, it's going to execute some code. So we want this function to stop at this point because it's bad. But we'd also want it to explain to us why it's stopping. So we could add something like a print statement here before it exits the code. So the return function makes it break out of the return function makes it break out of the function you're writing. And then maybe before it does that, you can have it have a print line and give you an informative message. So then after you check whether they're the same length, you would want to do a scalar product of these two vectors. And then you'd want to divide by the total number. So okay, scalar product is multiplying the vectors. And we learned from last class that we can, I'm pretty sure something is wrong with my brackets, but it's okay. We'll keep going. Oh, okay. We can calculate the sum of multiplying these two numbers. And if you remember, just multiplying these, the multiplication sign is going to just element wise multiply the vectors. So we put that input into a sum function so that it adds those numbers together. And then we can sum that second vector to get the total. Yeah. Yes, you can definitely do that. And let's do this for now. And we can compare them at the end. So if this is typed out correctly, then we would return z at the end, and that would give you your weighted average function. Okay. So we can test these. We can have x1 is equal to, let's say x1 is equal to the numbers 1 to 20. And we can say x2 is equal to another vector. So now I want to introduce you guys to another function. It's called the R-unit function. So this, actually, sorry, I will go back to the sample function. I'll introduce RF in a moment. So let's sample this list from 1 to 50. Let's sample it 20 times because we need to get a vector of length 20. And let's say replace is equal to true. Now we have two objects, x1 and x2, and x2 is giving you the frequency of each one. Now if we do my weighted average, x1, x2 returns 11.9. Sounds good. What if we just do the percent multiply? And if you recall from last class, that is the matrix multiplication function. Oh, I typed it in wrong. I haven't figured out how to see it correctly from the table. This doesn't give you the same number. Why do you think that is? So it gives us something 5,000 something. Say that again? Exactly. So if we do this, and then if we wrap it in parentheses and then divide by the sum of x2, it'll give us the same number. Okay. Let's try one more example. Let's say I had sampled it only 15 times. Now if I run this function, it throws this error, or it gives us this message. Okay, so thanks for playing along with this example I created. I'm going to spend some time now going back through a little bit of the material we covered last class. Then we'll move on towards how to use packages in R, and then how to import data tables, or how to get data into R. So first, I just want to do a review on the data types that we're talking about. So there are numbers, which we've been working with a lot by now. And those, standard numbers. So once you save a variable, give it a value 1, it ends up over here. If you run the function is.numeric on this is a number, it returns true. There are different types of numbers. So you can have integers. And the way you define those is by adding an L after the number. Now, if you run is.integer on this, it should return true. Okay. There are data types. You can also have characters. And those are different lengths of, they can be different lengths, and they can have different non-numeric input, like letters. And if you do is.character on those, it returns true. Okay. There's another data type that's very different from all those, and that's the Booleans that I was talking about earlier, or logicals as R calls them. And that's just, those only take 2 values, true or false. So this one's kind of special because that's also when we're running the is functions, that's what it's returning. It's returning a logical value that's either true or false, or NA, which is the null value. But that you shouldn't think of NA as one of the true false values, one of the logical values. So if we run is logical on this is a logical, it will return true down here. Okay. If you remember from math class, real numbers aren't the only types of numbers there are. There's also complex numbers, and so R can handle that. And if you recall, that's the square root of -1, or those are imaginary numbers. So numbers that involve imaginary components are complex numbers. And this is how you would signify them. Okay. And there's a corresponding is complex function. Okay. So when I run the is complex function, it returns true. So after talking about data types, we also talked a little bit about data structures, in particular vectors. So we can make a vector by using the C function, which is the concatenate function. And we can put numbers in there. We have vector 1 over here from 1 through 4. We can see that this is, we can check the data type of a vector by using is numeric. Okay, so that returns true. And we can also index into vectors. So this is kind of a new topic we haven't talked about yet. And that's taking an element out of a vector. So the way you would index into a vector is use this bracket notation. So it's one bracket, and we put the number in there that we want. So R is indexed to 1, which means the first element of a list is you use the number 1 to access it, instead of 0, which is more common in other languages. So if I do vector 1 and then put these brackets and put a 1 inside, that gets me the first element of vector 1. So vectors don't have to be just numerics. They can also hold character values. So if I do vector 2 and I give it these values like A, I can do B, C, do D also just for fun. Now if I run is numeric on vector 2, it should return false. But if I run is character, my computer's really slow today, on vector 2, it'll return true. You can also index into this. So I just want to show you. So if I print vector 2, it appears like this. And if I do vector 2, 1, gives me the first element. If I do vector 2, 2 to 3, gives me this. So this is itself a vector. But this object is only 2 elements long and only has the items B and C in the list. I could save this as another temp vector, let's call it. And it'll save as its own object that's only 2 elements long. You can actually also have vectors with mixed data types. So we have vector 3, and we can put in some numbers We can also put in some letters. We can also run these through the is functions. So it returns false for numeric and character. Okay, so in this case, when you try to put in numbers and letters into the vector, it noticed that there are different data types, and it actually converted the ones and twos to characters instead of numbers. So if you look into vector 3 over here, it has these quotes around the 1 and 2. So instead of recognizing this as a numeric, it is recognizing this as a character. So that's something to keep in mind. And something that where this might come up is you might open up a data set in R and you think a column is full of numbers, but somewhere way far down deep in the data set, someone put in not available. And so suddenly R sees that value and it thinks this whole column is full of characters instead of numbers. So when you try to run functions like mean or sum, it'll just throw an error. So this is something you'll probably run into. So just keep that in mind. And you'll want to try to convert characters that should be numeric back into numerics. And one thing you can do is you can run the as numeric function. So as numeric is different from is numeric. And if we run that on vector 3, so notice I'm not saving this object, so it's going to be a temporary option. Temporary operation, this function is just going to apply to vector 3, print the output to this console, and then it's just going to throw that in the trash. It's not going to save it. So now, when I run as numeric on vector 3, it forces the third and fourth elements of the vector to turn into NAs because R doesn't know how to convert A and B to numbers. Okay, so this is going to be a pretty useful function for you guys. Any questions so far? I want to stop for a moment. Yep.
Is there any function for large data sets that can identify which values are numerical factors that can find them that you can plot it in the different data sets? Large data sets.
Yeah. Okay. There is a way. How about I talk about that towards the end of class when we open up our data set? And yeah. So let me just remind me again if I forget. Okay. So we'll keep going on if there's no further questions. So vectors, that's one data structure. Or sorry, one data structure. You can have more complex data structures like a matrix, matrices or arrays. So a matrix or an array is basically it's a vector of vectors. So one way you can initialize a matrix is like so you can use the matrix function. Let's see. Specify the number of rows and the number of columns. Oh, that makes sense. Okay, so now we told this function to take the vector this vector from 1 through 4, but read it as if it had 2 rows and 2 columns. So that created this object. Actually, I've never tried to view a matrix, so let's see what happens. Okay, so it created this object that put 1 and 2 in the first column, and 3 and 4 in the second column. And it didn't know what to call these columns, or in the matrix notation, there are no specific names for columns or rows. Okay, so let's go back to our code. Oh, also, I noticed that I forgot to save my code. This is very bad practice. Always save your code. So I hope you guys will save this something like lecture 2, hopefully. Or you know, whatever is interesting to you. Make sure you're working in a project again so that just to get in the habit. Okay. Let's go back to matrices. Oh, and the way you index into a matrix is using the same square bracket notation. But this time you can have 2 indices. Let's see. So if we recall, let me print matrix 1 also for us. So matrix 1 looks like this, 1, 2 in the first column. So when we go to 2, 1, we tell the computer to pull up the element in the second row and the first column. Does that make sense? Okay. It's a little confusing, so if you don't think you've gotten the right index that you want, you try switching the numbers around and see if that works. It's what I do. Okay. You can also set up arrays. Oh, and these don't have, okay, so an array doesn't have to be 2-dimensional. So if we notice the matrix had rows and columns, but you can make an array have more dimensions than that. So we're using this dim argument to tell the array to have 2 rows, 2 columns, and 2, I don't know, temporal columns or something. Okay. Let's see how, did I get a question? Okay. Let's see how this prints on the computer. Okay, so this is basically setting up, kind of looks like 2 matrices, 2 2x2 matrices that, so the first one is between 1 through 4, and the second, and this is exactly like matrix 1 that we created. The second one has it, it's 5 through 8. So the way we index into this is the same. So we can, but we use 3 indices instead of 2. So this is telling the computer to get the first row of the second column of the second matrix. So that's how it is indexing. You can also add, you can also add a colon to get more than one number. Let's see. So this is getting 3 and 7. So it's telling it to get the first row of the second column of the first and second matrix. So it's a little confusing to understand, like why you would want this, but you can imagine having a data set loaded in R and you want to get the value of one specific individual. So then you would use this bracket notation, and you can pull up like like maybe the 100th row, and you can look up maybe the person's name. And I'll show you more ways that you can use this later. Yeah. So I wouldn't do that. I would store array. Instead of using an array, I would use a data set or a data structure that I'll talk about in a little bit called a data frame. Yeah. Oh, okay. I guess So arrays have slightly less overhead, so I get, I don't know. If you're just doing a purely mathematical operation, you can do an array, but you can't store, it doesn't store names of columns or rows, so it's not as nice for handling these data sets probably. Yeah, yeah, sure. Honestly, I haven't used this except for this class. Yeah. Okay, so we'll cover a few more data structures and then get to our favorite, the data frame. Oh, yeah, can anyone tell me what indexes you might use to get the 6 over here? 2, 1, 2. Okay, let's try it. 2, 1, 2. Okay, that's good. Great. 2, 1, 2. Yeah. Yes, actually, yeah, that's a great point. I'm just gonna repeat it again so the camera catches it. A lot of different packages will return inputs in arrays or matrices, so we'll have to figure out how to use those, how to manipulate those. Thanks, Duncan. Good point. Actually, that is how I've used these mostly. Okay. Then we have a list, which is kind of more free form than a vector. So you can have a list that has as elements vectors or other types of objects. So we can put in vector 1 in here, vector 2, vector 3. We can also put in matrix 1. Matrix 1 and array 1. So this is a function that I have used before. Later on, when we talk about data frames, I've like made lists of data frames. So it's kind of helpful. And when you index into the list, you will get the element that's living there. So if we do use 3 as an index, we'll get vector 3, which is this mixed data, like this one with letters and numbers. If I do, okay, so here's an important distinction. If you notice, I did a single bracket and I got vector 3, but I got this weird double bracket thing. So now if we use this function called str, I hope this works because I think it's going to. Okay. It tells us what kind of structure we're looking at. We're looking at a list of 1 item, and then it tells us that it's a character vector of length 4 and gives us the elements. But let's say we're not so thrilled about it being a list. The way we can get out of that is using this double bracket notation. So now let's see what this happens. Oh. And it takes me a second to get this each time. Okay. So instead of a single bracket, if we put the 3 in double brackets, now instead of this weird double bracket 1 showing up, it just gives us the vector. Now if I use this str function to tell us what kind of object this is, it should not give us list back. Right, so now it doesn't have any list in there where it used to tell us that it was a list of one. So this is like an important distinction. A single bracket returns back an element of the list, but it returns it back as a list of element one with that element in it. But that's probably not what you want if you're trying to take out an element from a list. You probably just want that element. So you can use this double bracket notation to like regain that vector that you put in there.
What is it? Thompson? Or Thompson?
I can,
Yeah, okay.
yeah. So you can use a double bracket to get the whole vector back. You can use the double bracket to index into the vectors that you put in. So if you remember, let me show you what vector 1 is over here. Vector 1 is this 1 through 4 element. So if I go into list 1, I take the first element, but then I only want to get the fourth element of that, it'll return 4. And I can use the same bracket the same colons to get like a range. Okay, so this is returning back the third and fourth element of that list.
In the bracket.
Within the bracket?
So we have the double bracket and bracket for.
Well, let's see what happens. I don't think it works. Yeah.
No, I mean like with like the bracket. We did like the list with the bracket. The list 1 bracket 3 4
Then what do you want to do?
then like that. Doesn't work. I just answered it.
Oh, yeah. What do you want to get out of this?
I'm just seeing that there's another way to write.
Oh, I don't think so. Yeah, maybe there is. You can also index into the matrix. So the matrix is the fourth element. We got the fourth element. Then we can do 2, 1 to get that 2 out. Okay. Just keep this in mind. We'll post the code. You can always go back through and play with these, and it's a little tricky, so you might have to look at it, play with it a little bit to get the hang of it. Okay, let's move on to factors, which is actually a data type. Yeah, it is a data type instead of a data structure, but it's kind of confusing, so we put it down here. So a factor isn't quite a character and it's not quite a number, but it lets you give order to a variable. So the way you initialize it is by using the function factor, and you can turn a string, or sorry, you can turn a vector, you can turn the values in a vector from whatever data type they used to be. So in this case, we're going to do characters into a factor data type. This is a factor. And what we're doing is basically giving the values of this vector like an ordinal value instead of just like a discrete one. So we can set the levels. So you have to set the levels of a factor, and we'll just call them we'll make the first level A, the second level factor. To this. Okay. So, okay, what did I do over here? So I created this object, and this object is a factor type vector, and it has 4 levels. But if let me see, factor 1. If I print out factor 1, it gives me back the vector I put in. This is a factor, but it tells me that the order of the levels is this. So even though A is the 3rd element of this vector, it's the first level in the factor. So if we check out what data type this is, it's not going to be a character. It's going to be a factor. Yeah, so if I run is character, it returns false. If I run is factor, it returns true. And if I use this levels function to tell me what the levels are, it'll return it in the correct order. Oh, yes. Yeah. Yeah, exactly. Another time that this might be useful is if you have a data set loaded in, and let's say one column is the number of vehicles people have, and people can have 1, 2, or 3 or more, and it says 3 or more in the data table. You don't want to code that as 3. You wouldn't probably want to code that as 3 into your data set, so you can use factors to code it as 1, 2, and 3 or more, and also keep the relative magnitude of these variables, like 3. You can say 3 is bigger than 2, 3 or more is bigger than 2, etc. It'll become more apparent later. But word of caution, like only use factors like towards the end when Duncan said when you're plotting, because weird things can happen if you make a column a character and then try to do some operation with it. Like it can give it a weird name. Okay. There's this n levels function also. Let's see. Tells you how many levels there are. Oh, right. So if we use this order function and we put in different vectors, so if we put in vector 1, it didn't do anything because our vector is already ordered from smallest to largest. But if we put in factor 1, it should reorder the elements. Okay, never mind. Sorry. It tells us the order function actually tells us which factor level each element is. So if you notice, our first element of factor 1 is this, but this is the. Actually, you know what? I don't know what order is doing. I will get back to you on this.
Order is doing, it's reflecting, you have a list, this is the factor, and order is saying that first list you set in, here is the place within the level that you set it. So like, it'll get 3, 4, 2. A is the
Okay.
like it's basically saying like you said A is 1, but in the list it's 3, so it's giving
Yeah.
before, but what place in the list.
Okay, right. Yeah, this is tricky. I forgot about this. Yeah, exactly what you said. I'm trying to say it for the for this
Oh, yeah.
this voice. So A is the third level. No, A is the third element in this vector, so it appears first. Factor is the fourth, so it puts in a 4 and so on. Okay, so let's move on. We can work more with factors on Monday. But I think we could spend some more time. Oh, I want to say one more thing about factors before we move on. So if we take vector 2, I just want to remind us what vector 2 says. It's I think it's A, B, C, D. We can actually replace parts of a vector pretty easily. So using our square bracket notation, we can overwrite an element of a list just by using our arrow operator. There we go. So now if I look at vector 2, okay, now if I look at vector 2, it is I'm gonna say A blah CD. But it's not so easy to do that with factors. So if I do factor 1 and I try to overwrite the second element with a random string, it says that blah is an invalid factor level, so it introduces an NA into our factor 1. Right, so now the second element is replaced with the null. Okay. We can work on some more factor stuff next class, but let's move on to data frames, which I think are pretty useful. So a data frame is kind of like an Excel table. It has columns and like it has columns that can be named, and let's see. Basically, when you import data into R, it'll most likely be a data frame or something similar. So we can create a sample data frame. Let's call it student data. And use a data.frame function. To initialize this. Okay, so data frames will have column names. So we will name them the columns and then give them values. So we'll have one column that's called student, and it'll be a vector. And we'll call them student 1, student 2, and student 3. Student 3. Okay, so we want to make sure we're inside this last parentheses. We'll go in and make another column name. We'll give them ages. Okay. We'll give them ages, and they can be 24, 25, and 27. Okay, we'll give them genders. Okay, we'll make this one a factor. Why are we gonna make this a factor? Okay. Another reason you might want to have factors is to make sure there's only a like a definite number of values a variable can take on. So let's so this is going to feed in a vector that will then be converted into a factor with these levels. Sorry, I'm having a lot of typos today. And then let's give them a math score. And let's give them a verbal score. Okay. Yeah.
Why did you,
You don't need to. Alan's code is set up like this. It's just an example to show how you could set up a factor.
so what's the benefit?
Okay. So if you set up factors, if I accidentally, okay, let me set this. Let me hit enter on this. If I later on try to take my data frame and I'm overwriting a column and maybe I get confused. I wanted to change a student's name or math score, but I instead indexed into gender and I typed in 660. It'll throw an error. It'll be like, that's not a valid factor level. Yeah. Yes. From putting in a value that shouldn't belong in that column. Yeah. Yes. Because with character columns, like you can put anything in there and it's not going to throw in any problems. Like if I tried to go into a math score column and put in a character, it would return an error. But if I try to put numbers into a character column, it'll do it without any problems. It'll convert the number into a string and then put it in there.
But let's say we have
Yeah.
Would there be any for us to go that way? Take the other like character specific like variables and make factorize is that for
Yeah, well, like Duncan was saying, mostly would make it a factor just so that it plots nicely. Like if I have cars,
but
Right.
that won't happen to you. And
yeah,
so you don't want to go in as a matter of
yeah. What are you gonna say? Yeah, go ahead. Hmm. That's true, yeah.
So it's more like, make, yeah, to visualize the data as opposed to like
Yeah.
manipulate or.
Yeah, but even if you want to like make a summary table at some point, yeah.
Right.
Okay.
So is that good? Like run the code and then it is just the app that goes to the run the data frame and see it.
See.
It's still putting in and you not changing.
Oh, yeah, so it doesn't change the order of the data frame, but if it changes the order in which it, how do I say this? Like, if I try to order it, then it puts F first. So it stores the order kind of like, let me see, in the background. And once you run an ordering function on it, then it will. So if you notice, like when I just open up the data frame, like the numbers aren't necessarily in order. Well, maybe I. Oh, it would do it
Okay,
alphabetically.
now the one, the order that you specified.
Yeah.
So then keep it back, so it's like
And, yeah,
N, B, F, and M, which is
yeah.
not alphabetically correct, right? And then if you did like, ascending, then do N, B, F, and M, like four.
Right.
So to override the alphabetical or the ascending descending order.
Yes.
That's by default data.
Yes. 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 Okay. So now that we've made our data frame, we can print our data frame. So I clicked on it over here to open it up in another tab. You can also have it print to the console by just running the object, just like how we're running vectors. And this is how it prints it. It's kind of nice. Puts tabs so things are lined up. So you can run different functions on this object, which is a data frame. Oh, come on. I'm having a lot of trouble spelling today. Okay, so if we run this function, this is called the summary function. It tells you how many elements are in the data frame. Sorry, it tells you statistics on every column in the data frame. So for numeric columns, it gives you min, max, mean, and quartiles. For the non-numeric values, it tells you like the counts. Oh, so this is a factor one. For the character columns, it just tells you the length. So I briefly talked about this str function earlier. This lets you inquire, like lets you see what kind of object, what type of object a variable is. So like, you can use str on student data, and you'll notice that it tells us it's a data frame, data.frame. It tells us the names of the columns, what data types these columns are, and then it just lists the values there. Okay. Yes. So you said first column. So the ways you can index into a data frame, you can use this $ operator, and then you can just type out the column name. Oh, yeah, let me tell you. So we can use this function called names to get all the column names of our data frame. So these data frames really operate on like a column basis. So it's very easy to do column-wise operations. It's less easy to do row-wise operations. So you'd probably want to think about that one if you're collecting data or trying to import data. So you can use this $sign operator to get a column, and you said you maybe want to get like just one row.
Yeah.
So then you can use the same bracket notation. You can get so you can get the name of the second student. We can also do our oops. We can also do our normal bracket notation. And so the first element is the row, and then the second element is the column number, the column you're getting. You want. Okay. So you could also get all the whole row, like one whole row of data by doing one and then putting nothing in the second element of this bracket. You could do the same for columns by keeping your first element blank and then putting in a number. So in this case, we'll get the third column of the data frame. We can, like I was doing earlier, we can use our colons to get more than one value. In this case, if we put it before the comma, it'll give us more than one row, rows 1 and 2. And if I leave this blank, it'll again give me all of the data and all the columns, but only the first 2 rows. Okay. And yeah, I think we have covered all the ways we can do that. Oh, and we can also instead of indexing with numbers, we can use the names of the columns this way. So if you look at the elements and okay, so everything before the comma in the first element inside the brackets is a row. And the second element inside the brackets is a column. So you can put the name of the column. Oh man. Put the name of the column. To get it. This should work actually. Okay. So this is the same as is it the same as this one? That's the same as running this one. So you can either use the number 2 or the column name to get that column. You can also get multiple columns. You can use the column names and get multiple columns by using your C notation. So you can do ages, and then we can do math score. You can actually also change the order of that. If the order in which you retrieve something doesn't have to be the order that it's stored in the data frame. So I can ask it to give me back all the rows in the data frame, but I want the columns in maybe in reverse order. I don't know why we want that, but we do. We'll get all of the columns. And just like I was talking about earlier, we can overwrite a specific value in the data frame with our arrow notation. Okay, so let's say we want to update one student's verbal score, student 2's verbal score, let's say. Maybe they studied a lot, they did really well, and they somehow got a 700. I don't know what the max is. Oh no. Oh. This is interesting. Yeah, when something goes wrong in R, just run your code again and then see if it works. That's a pro tip. Oh, also, okay, don't do this now, but if you are running into a lot of problems and you just can't for the life of you figure out what's going on, always just like restart your R. That's gonna erase everything in your environment and it's gonna unload, you'll have to reload all your libraries. But if you are lost, if what you're doing isn't working out as it should, it's okay. Just restart R. It's probably something, um, something is overloaded or something is going wrong in the background. Okay. So, oh yeah. So we can do operation, we can take a whole column of our data and treat it as a vector. Yeah. So if I run this, it gives me all the value. Okay, so it gives me all of the values in this column. I'm gonna copy this so I don't have to keep checking it out. I can check, I can do logical operations on it, check whether each value is greater than or less than some value. I can, okay. I can also subset all the rows or all of the entries in this data frame in which this verbal score is less than 510. Okay, so let's kind of dissect what happened over here. So if I run this line of code, it gives me a vector of logicals. So true, false, false. That if I put this bit of code as the argument into our brackets, it's like putting true, false, false into like it's like indexing true, false, false into this vector. So this vector has 3 elements, 500, 700, 800. But when you do true, false, false, you're only getting the first element, which is because it's set to true. Let me give you another example. I feel like I didn't do a good job explaining that. If I do false, false, true, true, this will only get the second and third elements of my vector on the left of to the left of the bracket. So in this case, it's giving me the second and third element. So this is another way of indexing. Just like you can use numbers to index, you can use logicals to tell which elements of the vector to pick out. I'm gonna stop. I'm gonna pause. And any questions on this? I'm happy to give some more examples. I know this was a little bit strange. You can also, let's see if this works. Oh yeah, that's strange. Okay. Oh, okay, moving on. We can overwrite a specific element. We can overwrite a specific element of our data frame without indexing exactly which value that is by using these like logical statements. So like let's say we want to take any score that's less than 510 and give it a curve, make that actually 520. So before when I ran this code, it returned 500. But now I'm going to overwrite that 500 value with 520. Now, if I look at my student data table, this first verbal score is 520 instead of 500. Okay. We will save this part to maybe next class. Okay. Let us now work with that data set that you guys have downloaded on your computers. So we didn't talk about this too much yet, but there are different types of packages that we can use in R that can make our lives easier. So one thing that I like to use a lot is dplyr, and specifically I like to use tidyverse, which is a package that includes dplyr in it. So please try to load these libraries. If you haven't run these before, the command you use to get a new package is install.packages. And then you will type the name of the package you're using. Okay, this might take a while. So can you put your hands up if you are currently trying to download tidyverse? Oh, everyone has it. Okay, good. But feel free to run this in the background. And I'll talk about a few more packages you can load. You can also use there's a package called data.table, and so Alan really likes this package. For the remainder of class today, I'll only show you examples in tidyverse. Well, okay, I'll show you one example in data table, but we'll work mainly in tidyverse. And you'll get more exposure to data.table next week. Okay. There are some other functions like readr and lubridate. Lubridate is good for working with date time objects in your data. You'll probably go into that next week. So let's okay, is anyone currently working on installing packages? I want you to have tidyverse and data.table for the next examples I'm using. Okay, no worries. Does anyone else have this problem? Can you look on with a friend? I don't know how to fix that. I'm sorry. Okay. Well, we're not going to do too much today, so if you can look on with a friend, and this code will be posted. He's got it? Oh, perfect. Wow. Okay. That's crazy. Better than Canvas. Okay, so we're gonna look at loading data in, and we're gonna compare some base R. So far we've been working in R without loading any packages called base R. And we'll compare it to my favorite dplyr and data.table, which is actually probably better than dplyr, but we'll get to that later. Okay, so let's we are going to check to see how fast each of these things is. And from last lecture, we know that we can read in the time on the system by using this system time function. Then we're gonna open up this data table as a data frame. We're gonna call it covid.df, df for data frame, and use the base R function. So the base R function is read.csv. The dot is very important. You'll see why soon. And then so do coronavirus underscore db.csv. So for this to work, this file has to be saved in the directory that your project file is in, or it has to be in your working directory. And then let's print, you can do the path on it. Yeah. I don't like to work like that. Yeah. Yeah. Okay, so let's run this code and see how long this takes. So this is the base R function. My computer is really working hard with Zoom and everything, so it's gonna take a long time. But the next thing we'll look at, so this took 12 seconds, and that's not great. Now let's look at dplyr. Yeah, you don't want that. You don't want that if you're working on a lot of things. So I'm just gonna copy and paste this code. It's gonna be very similar. There's gonna be some differences. So dplyr, what's interesting about it is that instead of creating a data frame, it works in these things called tibbles. And tibbles are almost identical to the data frame, so we don't have to go into too much depth. I think one thing that makes them different is that they print more nicely to the console. Yeah. But when you're working in tidyverse, they're usually going to be tibbles. So let's call this data.tb for tibble. Yeah. And then this function is going to be read underscore CSV. Okay. And so this is using dplyr, which is a part of tidyverse. So I'm going to highlight this section of code and run it. You'll see that's way faster. It was 3 seconds instead of 12 seconds. Okay, now let's use data.table. This is actually going to be the fastest of the three that we're looking at. Are you still working on installing the packages? Okay, perfect. Sorry, I'm going fast. I just want to cover a few things before we run out of time. Okay, so data table works with data tables instead of data frames. And those are pretty similar to, it's kind of more optimized, this whole package. And it works better for a really large data frame. And by large, I mean, like you'll have a million observations, like maybe have like 2 to 3 million observations. It might be 30 columns, something like that. I don't know. And it's not a very precise measurement. Don't quote me on it. But I usually work in tidyverse and dplyr. I've only recently done a little bit of data.table because I've been working with these huge data sets. So my personal approach is to try something in tidyverse, and if it takes too much time, then switch to data table. But Alan works, I think, mostly in data table, so you'll get exposed to both types of structures in this class. Okay, so the data table function is fread, and it gets stored in a data table. Let's run this. Yeah, and this was less than a second, so you can see it's very efficient. Good stuff. Okay, so if you notice, I have 3 different objects stored now, and we'll do a couple. Okay, so we can do the summary function. We can do the summary function on let's see, COVID.tibble. We can run the str function on COVID.tibble. So if when we run the summary, we get the min, max, and other values of each column. Okay, so we've got cases, we've got deaths, we've got state. And we can do this column called, and then when we run str, it tells us that this is actually a tibble, TBL, not a data frame. And then we can also look at n rows of COVID.tv. And so you can tell how many rows it is. You can also see that over here, it's 2 million. Oh, okay. Yeah, this is a fine size for us to be looking at it in dplyr tidyverse, but it will definitely be faster in data table. It's just like more optimized. I don't know. I don't know, the inner workings of the package. Yeah. Okay, we've got 20 minutes. Okay, so I'm gonna show you a few simple things that we can do with dplyr. So if we take our data table, we might, if we looked at the summary, we can see there's a date, there's county, there's state. So we might be interested in, okay, what are some things we might be interested in? Why don't you guys tell me? Counting the highest deaths. By what? By entry? On a date, maybe? By county. We can do it by, okay, let's do that. Okay, the county with the highest deaths in California. Let's do that. It's very sad. Yeah. It's, I'm forgetting. It's something like zip code or something. It's not zip code, but it's like a smaller designation than county. I will get back to you. I forget. Oh, you think it is? Oh, okay. Oh, then okay. This is okay. This is the code for a county, but this is across the whole U.S. It looks like then. Okay. So I want to illustrate a concept. So we're gonna make a new column. So in tidyverse, we have this operator called the pipe, and that's this percent sign greater than sign, another percent sign. I use Control Shift M on my Windows machine to get that shortcut. I don't know what's on Mac. Sorry. And in tidyverse, this pipe sign basically lets you chain operations. So what happens is that everything left of the pipe ends up being the first element in the function that's after the pipe. And one function that you may use a lot is a mutate function. So mutate lets you add a new column to a data table or a or to a tibble or to a data frame. Mostly tibbles though. You should, if you're working in tidyverse, maybe convert your objects to your data frames to tibbles. So maybe we want to see we want to make a new variable that's like what percent of cases lead to deaths. Very important. Like when we were looking, one concern that happened in COVID was that maybe we're undercounting cases. So if there's maybe a really huge outlier when comparing deaths to cases, you can see maybe what areas were massively underreporting their cases. So you might do deaths. You might call this deaths cases ratio or something. So this is going to be the name of our new column, and then we are going to populate it with just dividing deaths by cases. So when I hit enter, this did not save a new element into my environment, but it did created this new column. One thing I like to do is I use the pipe operator, and then I put everything into a view, so that it will show up in a new screen. But it still hasn't saved anything. And I just do this because I don't want to be creating 1,000 variables all the time. Although maybe you want to save things more often. Ooh. Okay, yeah, this data set is huge, so it's very hard. Oh, this is a nice problem. So we run into some cases where we're running to infinity because we're trying to divide by 0. So that's very interesting if you can have depths without cases. Let's just leave that in there for now. We'll handle that another time. So one thing we wanted to do was maybe group by county and see who has the highest number of deaths. So if we look at how this table is organized, it looks like there's each row is a date, a county, the state that the county lives in, and the number of cases, the number of deaths. So in Tidyverse, there's a function called group by, and it lets us choose different variables to group the data by. So let's just look at county. So this is going, so if we just group by county, we're going to ignore differences over dates, etc. And maybe we also want to know what state this is in. So let's actually group by county, state, and FIP. And then we can use the summarize function to calculate the number of, say, deaths by each county. You can enter. Okay. Oh no. Okay. Okay, so this sums the number of deaths across all counties. We can also do total number of cases, so that we have everything just for just to be thorough in this. Okay, if you notice when I ran this code, it says that our groups are county and state. Basically what's happening is that every variable that gets put into the group by function creates a kind of groups our data, is grouping our data. Once we run the summary function, it ungroups by one of those columns, but we don't want it to be grouped at the end. So we're going to run this function called ungroup, so that our, oh, I have to put a comma in here, so that our final output is doesn't have that weird grouping. Okay, so this is how we can add some columns and do some grouping. We'll do more on this on Monday. But I know we don't have so much time, but I want to show you guys something real quickly. So far this is an R script. It's a .r file. But for this class, you'll have to submit homework in an R Markdown using R Markdown. So what we expect is for you to create an R Markdown file. So if you go to File, New File, and then if you select R Markdown, oh my gosh. Okay. I will do that on my screen here and then bring it back. So file, new file are markdown. It should pull up the screen. And you'll do something like call it lecture, or you'll call it like homework 1 or something, but I will call this lecture 2 in class. And you will have to submit a PDF, so select PDF and hit open. And so that populates this this document, and it has your name. It has some code. Don't look at this real quickly. Okay, so the way our markdown is set up is we have the hashtags. So our markdown is different from our scripts, but you can have our scripts, you can have our code like within these files that executes and returns output. So for example, these 3 backticks, it's kind of hard to tell, but there are 3 backticks that indicate that you're going to enter a code chunk. Then there's a curly bracket, and then the letter R, and then some more information. And you need to have 3 backticks to stop your markdown. So this is all auto-generated. When you open up any new R markdown, you'll see this code. But basically, R markdown is used to write up, to create files that add commentary and run code. So if you wanted to make an R tutorial, you can use R markdown to create a HTML web page, or if you want to make a whole book, you could. So when you look up if you look up our help, you often see kind of like books online with chapters. It's probably built with R markdown. So I want to show you how you might use this for your homework. It's pretty important. So you would do 3 backticks, type the letter R in, and then you'd finish this chunk by doing 3 backticks. And then inside here, you would put in R code that you would run. You would want to run. So for example, I'm going to open up this simple file I made. It has code chunks from last class and today's class, but just a little bit of it. So I have the isPrime function we did last time, and I have the student data frame that we made today. You can just, if you are following along, you can just copy and paste the student data frame in a new file, but it's getting kind of tight, so maybe we'll go over this again on Monday. So you can take your R code. I can source my this file I created. So I'll call it lecture 2. Yeah, I can source the script. So this will basically run the code that I've created in this other file, and then let it print something. So I can print isPrime 13. Okay. I think I saved this in something called lecture 2, so I will. To run an R markdown script, you have to hit this knit function. I guess, yeah, for next class, make sure you've try to knit an R, you can just try to knit the default R markdown file and see if you run into problems. Try to generate a PDF. Yeah, I guess. Yeah, so I was talking about, so knitting runs this R markdown file and creates a PDF. You can also hit run to run chunks of code. I've never done it like that, but if it works for you, then I guess that's good.
To make sure it looks.
Yeah.
But if you do test it and you can, it would automatically do it. Yeah. Right.
Okay, so if I run. Okay, cool. So if I let me hit knit and it'll ask me to save this file. So I'll call this lecture 2 in class. I'll figure out why this isn't running later, but just try to open an R Markdown and have it compile the default file for today, right now. Yeah. Uh-huh. Okay, so if you put get PDF, it works.
That's that. I do the neighbor and I save it. I thought neighbor, the neighbor, I don't have it.
Oh, these. Oh yeah. Yeah. Okay, I expect everyone to run into problems at this step if they haven't made an R Markdown before. Because you have to download some packages, so let me know. I think it's the same. This knit R.
Tiny versus the fires in the car.
I'm not sure. Yeah. I know that when you run this for the first time, you have to download some extra packages so that it works with PDFs. How many people have, okay, have you successfully compiled a PDF? You should get something like this. If you're, just open up the default template and compile it. Can I get hands if you have a PDF like this on your screen? Okay, good job. Yeah, I know, this is where we run into problems. Okay, we've run out of time for today. So we'll continue on Monday. Thanks for coming, guys, and we'll set up our office hours soon, so. See you there. You have to do library tidyverse in the code, yeah, somewhere.
So you have to do this. So like if you have multiple different chunks.
If you
put
do
it in the first chunk.
Yes.
So you
Yes.
can insert a chunk where it's like reading everything, hide that chunk.
Yes.
And then it'll treat, okay.
Yes. And you can come find me now if you have questions. I don't think anyone's in here.
So
Next.
Even if you have a large scribble, it doesn't recognize.
Yes. Yeah, it's a blank blank slate.
Okay, so basically I load it in and I'm saying did it.